So in this video, I'm going to be discussing lab 7, and in this lab you're going to be identifying some unknown substances, two of the unknown solids, and then an unknown liquid. So, how would you identify a substance when you don't know what it is? All right. There are properties which are extensive, which can't really identify a substance. That would be like mass and volume. The bigger the substance, the more of it you have, the more stuff you have. That means the more mass, the more volume you have. All right. So, some of these extensive properties like mass and volume are quite visible, whereas there could be others like energy which may not be visible. But the key way to identify a substance is through its intensive property. And then we talked about this a little bit in lab 3 where I mentioned density. The density of water is 1 gram per mil. So whether you have a small teaspoon of water or whether you have a fish tank full of water, its density, as long as it's pure, is going to be 1 gram per mil. All right. Other intensive properties. So this is irrespective of the sample size. All right. So the boiling point and melting point also are intensive because it's irrespective of the sample size. So say if you had 100 grams of water and you tried to boil it, it would boil at 100 degrees. Suppose you had 1,000 grams of water, 10 times more than this, it would still boil at 100 degrees centigrade. If you had a fish tank full of water, it would still boil at 100 degrees centigrade. So intensive properties are not dependent on the sample size. It's not dependent on the amount of stuff that you have, all right? And therefore, those are factors that are key to identifying an unknown substance. And that's what we will be using or determining in this particular lab. Okay. So what you have to do is choose from some unknown solids given on the shelf. You'll have to choose two of them, solid number 2 and solid number 4. And for the liquids, liquid number 7. All right. And then you're going to measure some of their intensive properties like density, melting point when it's a solid. Of course, you can't use melting point as a criteria to identify a liquid, but you can certainly use boiling point. All right. So the solid is mainly going to be identified either by its density, its melting point, and also another key factor is a solubility. Now there are certain solids that are highly soluble in water, whereas other solids are kind of medium in their solubility in water. And then there are yet other solids which barely dissolve in water at all. Okay. So then you'll take the values that you obtained from the experiment and then compare your values to that which is known from the literature. All right. And that's how you will identify your unknown substance. So here are some known values for some of the listed compounds here. And then as you can see, the names are given, their formulas are given in this column and their densities. Now these are solids, of course. They are going to be having higher densities as compared with water. And then if you look at solubility, solubility is measured at how many grams of this solid is dissolved in 100 mils of water. All right. And the higher those numbers, that means they're very soluble in water. So silver nitrate, very soluble in water. Zinc nitrate also is quite soluble in water. Whereas if you look at these numbers like 56 and 40, that means this kind of soluble, a little bit of it dissolves, but for the most part, they're not as soluble in water. Now, when the numbers are either zero or close to zero, that means they do not dissolve in water at all. So, for example, calcium carbonate is zero. So, limestone is not soluble in water. And then if you compare their melting and their boiling points, each one has a characteristic melting and boiling point, all right? So these are some known values, and then you'll use your values to compare with these known values. If you come to the liquids given to you with the known values are listed here: acetic acid, acetonitrile, cyclohexane, cyclopentylamine, and ethanol. Now, most of these liquids have fairly low densities as compared with water, which means if they're less dense than water, they're going to be like floating on top of water, much like oil floats on top of water. Acetic acid has a comparable density with water, and these are their listed boiling points. And again, those boiling points seem to be relatively low except for cyclopentylamine and acetic acid, which kind of compare with water. Alright, so in the first part, you're going to take a test tube from your container shelf, add 10 ml of water to it, and add 1 gram of solid number 2. See if it dissolves. If it doesn't dissolve at all, then you're going to record in your notes as insoluble. All right. If it's somewhat soluble, then go ahead and add another gram. Again, check for the solubility. If it does dissolve, try to add yet another gram. All right. So go in increments of 1 gram till you get to about 5 gram. All right. Now, if all of that 5 grams dissolves, then of course the solid is soluble. But if some of it dissolves but the rest remains undissolved, then it's slightly soluble. That's what you'll record in your notes. Now, from part 1, you're going to, if it is soluble, then you can just skip part 2, because if it completely dissolves into water, then there's no way you can determine its density by volume displacement. However, if it is only moderately soluble or almost insoluble, then you can use volume displacement to determine its volume. And since you know its mass, you can then take the mass and divide by the volume. So what you're going to do is take a graduated cylinder, and to that you'll add 20 ml of water and take the mass. Now then zero it and add 10 grams of the solid number 2. So if solid number 2 is not very dissolvable in the water, then the volume will rise in the cylinder, and note this new volume. All right. So the final minus the initial volume, the final volume minus that 20 would give you the volume of solid number 2. All right. Now note the mass. Take the mass, divide by volume to get the density of solid number 2. Okay. Now take a clean test tube and add to it 5 grams of solid number 2 and take it onto a Bunsen burner and start to burn it to melt that solid. All right. So as the solid is melting down, the temperature will rise, but then when the solid is melted, all of it is melted, the temperature will kind of stay constant. All right. So be careful while watching for this temperature. Where the temperature is not moving too much and it's staying constant, that's the melting point. Right. If it doesn't melt at all, then record the highest temperature that you can go, and so on. So anyway, repeat all these tests with solid number 4. So you're testing for both those solids, and then you're trying to take the data and identify both solids number 2 and 4. Now, liquid number 7. So take 10 ml of liquid number 7 into a graduated cylinder. Note the mass and then divide that mass by 10 to get the density of liquid number 7 in grams per ml. Take another clean test tube, pour into it 10 ml of liquid number 7, attach a thermometer to it. Now take that test tube and start burning or heating that liquid. Again, wait till the temperature stays constant and you see some vapors arising. That's you know that you've reached the boiling point. So note that down. So what I found was solid number 2 was kind of slightly soluble. Its density was around 1.6 grams per ml. Melting point about 168.5. So I identified solid number 2 as ascorbic acid based on these above mentioned intensive properties. Make sure you do the same thing, record the density melting point of solid number 4 as well, and then identify it with the given values and identify what that solid number 4 is. So the two recorded intensive properties for liquid 7 was density 0.86 gram per ml and the boiling point 107 degrees centigrade, and based on those two properties I identified liquid number 7 as being cyclopentylamine. So the aim was to identify solids 2 and 4 from their intensive properties of density, solubility, and melting point, mainly density and melting point, and then identify liquid number 7 from density and boiling point. The hypothesis is that I predicted solid number 2 could be slightly soluble, in which case it would be easy to then obtain its density using the volume displacement method. All right, and since it kind of looked like a powder and not a crystal, I predicted its melting point to be low. Okay, write a similar or write a hypothesis for solid number 4 as well. So again, list all your materials, and then write down your procedure, and then a very detailed listing of your observations or data. Okay. So as I said, my results indicated that solid number 2 was ascorbic acid, and liquid number 7 was cyclopentylamine. I didn't test solid number 4, so you would have to list here in your lab reports what you think solid number 4 was. So what are the conclusions? So I learned that if I come across an unidentified substance, the first thing is to dissolve it in water. If it is an ionic compound, it's going to be in most cases quite soluble, not necessarily all cases. All right, ionic compounds have high melting points, so I would not necessarily be able to do a kitchen chemistry experiment to determine what my unknown solid is, especially if it's an ionic compound. So if the substance is ionic, another way to confirm is to find its density, right? Again, just try as best as possible to determine the density in terms of mass and volume. If it's very soluble in water, then it's not likely that I'll be able to use volume displacement. All right. If it is non-ionic, then the chances are it's not going to be very soluble in water, and therefore I'll be able to melt it quite easily on the stove top. I would be able to even determine its density. I will have to stop here and continue this in the next video.